Hey guys, today I'm going to lecture over 5.3. This is all about the unit circle. So the unit circle has a lot of information on it, so I'm going to try to get through it as quickly as I can while making sure that you understand the concepts, but there is a lot to unpack here. So before we start talking about what the unit circle is, we need to talk about trig functions in the plane again. So you guys, in our last section, we found some trig function values in the plane for angles theta, but usually we don't know what theta was in those cases. We knew x and y, and we found r, or we knew some combination, we found the other one, and then we used x, y, and r to find all the trig functions for a specific theta. But today, we're going to talk about trig functions for actual angles that we know. So we have what we call special angles, and their trig functions are easily found using those special right triangles. So if you remember, we had some special right triangles. We had the 30, 60, 90, and we had the 45, 45, 90, and their side ratios have this cool relationship where it enabled us to find sides of all the triangles even if we only knew one of them. So we're going to use those today. So that gives us three special angles that come from those triangles. We are going to talk about the 90, but right now I want to start with these. We're going to start with 30 degrees. Now, because we know how to find radians now, and a lot of our questions are going to be asked in radians, I want you to get used to the fact that 30 degrees is also pi over 6 radians. 45 degrees is pi over 4 radians, and 60 degrees is pi over 3. So you could find those out using your degrees to radians conversion, using the pi over 180, and this is what you would find. But at a point, you want to just know these because we use them so much. So I am going to make an angle in standard position. Here's the initial side. Here's the terminal side, and the angle created is 30 degrees. That's where we're going to start. We want to know what the exact trig functions are for a specific angle, 30 degrees. Now remember, what I did last time was I drew the angle in the plane, and I made a point xy that it went through, and then I dropped it down and we created a right triangle so we could find x, y, and r. We're still going to do that, but you guys, do you think it matters where I choose this point to be? Well, it doesn't. You guys, if I pick this point here and I drop down, you can see a small right triangle it creates, and I could find the side length, so I can find x, y, and r. But notice, I could pick a point out here. It would be a larger triangle, but because the angle here is exactly the same, it's actually a similar triangle. So even though the sides would be larger, the ratios between those sides would be exactly the same. So if it doesn't really matter what point I choose to drop down a triangle, I'm going to use one that's easiest. So here's what I'm going to do. I am going to use this point. Now, I don't know the coordinates of this point yet, but I know that the length, that r, from the origin up to this point is 1. You guys, my goal today is to pick points on each of the angles I use where the radius from origin to this point, or the hypotenuse, or r, you guys, I want r equal to 1. It makes our lives so much easier. So let's drop down our triangle. So I have a right triangle, and all I know is that I've chosen the hypotenuse to be 1. I still don't know the x, y coordinates of this point, but I can find them. Remember, the x coordinate will be this length here because we went over x units to get there. And the y coordinate will be this length here, this up and down section. So do I have enough information on this triangle that has a 30-degree angle right here to find x and y when I only know one side? Well, yeah, guys, let me blow it up a little bit for you. If this is a right triangle, and I already said that this angle is 30, what is this angle up here? Well, it's 60, right? So what I'm looking at is a 30, 60, 90 triangle. Remember, in a 30, 60, 90, if the short leg is x, the hypotenuse is 2x, and the long leg is x root 3. So that's something we already know. Which piece of information do I have about this triangle? I have the hypotenuse. So what I'm saying is 1 is like the 2x here. Let's solve for x, and then I'll find the length of the short side. So if the hypotenuse is 2x, and I know the hypotenuse equals 1, if we divide by 2, I get x equals 1/2. And I don't want to confuse you here. The x, remember, in our little side relationship triangle, the x just means the short side. How it relates to this triangle here, it's actually giving us the y value, because the y value on this one is the short side. But what I found is the short side is 1/2, which means I just found the y coordinate of this point right here. All right, so how do I find the long side? Well, now that you know the short side is 1/2, remember the long side is just the short side times root 3. So this long side is going to be 1/2 times root 3. I know this isn't a fraction, but you can do it like this, put it over 1, so you know the root 3 is going to go on top. And I'm going to get the value of my long side. So I'm just going to have a root 3 on top and that 2 on the bottom. So you guys, I found all the sides of this triangle. Now you might wonder, 1/2, root 3 over 2, those don't look like the easiest values to find. But I'll tell you why I picked the point that I did. So you guys, this point where I just found x is root 3 over 2 and y is 1/2. Remember, my goal here is to find all the trig functions for the 30-degree angle. How do I find trig functions? Well, I use x, y, and r, and I make the ratios. Okay, so for the 30-degree angle, x is root 3 over 2, y is 1/2, and r is 1. Remember, I chose r to be 1. Why do you think I would do that? I was going to write theta, but we know we're looking at 30 degrees. So the sine of 30 degrees. Sine is always y over r, right? But you guys, r is 1. I chose r to be 1 for this specific reason. I could say that sine is y over 1. Or I could just say sine is the y coordinate. You guys, if r is 1, then your sine of whatever angle you're looking at, as long as you've created this hypotenuse or this r value to be 1, the sine's just going to be your y coordinate. What about cosine? Well, with that r being 1, cosine is x over r. So that's x over 1, or just x. So you guys, wouldn't it be nice if you could just look at the xy coordinate and say, oh, the y value is the sine and the x value is the cosine. You guys, that's very helpful to us. So you guys, what is the sine of 30 degrees? Well, here's 30 degrees. Here's the point it goes through. It's the y value. It's 1/2. So you guys, the sine of 30 degrees is 1/2, and it's always 1/2. And that's something you want to remember, you know, put that in your head and remember it. The same for the cosine. The cosine of 30 degrees is this x value, root 3 over 2. No r has to be, well, r is involved, but we don't have to put it in our calculations because I already told you r is just 1. So that's kind of cool. Sine, in this particular picture, sine is just the y value and cosine is just the x value. I am going to make some space here because I think it would be really beneficial if we could use this relationship where r is 1 to find trig function values for some of our other special angles. So you guys, right here, I'm going to write in the xy coordinates of that point on the angle. Remember, x was √3/2 and y was 1/2. And that coincided with the cosine of the angle and the sine of the angle. Let's make another terminal side. This one's 45 degrees. So I pick the point on the triangle that I want to make. So you guys, I've picked this point here. Again, what point is it? It's the point where r is 1. The distance from the origin to the point I chose is 1. So you guys, the triangle I've created this time is this one. Because I know this is 45 degrees, I know this is also 45 degrees. I'm looking at a 45, 45, 90. What do I know about those? Well, I know that these two legs are exactly the same. And I know the hypotenuse is where I take the length of one of the legs and I multiply it by the square root of 2. So if I already know the hypotenuse because I chose the hypotenuse to be 1, then 1 is going to be that x √2 value. I can solve for x to find the length of both of these sides. I just have to divide by the square root of 2. So I get this side to be 1/√2. And I know I'm not going to leave it like that because I rationalize, right? So we multiply top and bottom by √2. And what we get is √2/2. You guys, this is both sides. So think about your triangle. Remember, and I'm going to erase our 30-degree information as not to be confusing. In the 45-degree angle we have here, that means we've gone over √2/2 and up √2/2. Okay, I'm going to have to erase that whole thing. I promise I'll write it all again. So, did I find x and y? Yeah, remember, x is how much you go over here, y is how much you go up. For this particular angle, x and y are the same. So what does it mean for the sine and cosine of the 45-degree angle? Okay, remember, sine is y/r, but again, I chose r to be 1. So sine is really just y. So I just pull my y coordinate, and there it is. That's the sine of 45. The cosine of 45, x/r, but r is 1. So cosine is just x. So guys, notice that the sine and cosine for a 45-degree angle are both the same. And that's, the reason that happens is because in the 45-45, these two angles are exactly the same. So sine and cosine are also going to be the same because opposite and adjacent are the same value. All right, so there's the 45. I'm not going to do as much work on the 60 because it should be pretty easy since we already did the 30. So let me draw this again. You guys, let's talk about 60. So our angle is here. And I want to drop down a triangle. Where do you think I'm going to pick a point on this terminal side? Well, I'm going to pick a point where r is 1. So I pick that point, I drop my triangle down. You guys, I am looking at a 30, 60, 90 again. It's backwards this time, right? You guys, so instead of the 30 being down here, this is the 60 and this is the 30. When I am looking at a triangle and the angles are here and they're flipped in the 30, you guys, when you flip the angles, all that happens is your x and y flip. So you guys, if I did the work, if I used the concept of special triangles to find these sides, what I would find is that this time the x value is 1/2 and the y value would be √3/2. remember, it's still a 30, 60, 90. This relationship still holds. Notice the short side is now x and the long side is now y. So for 60, remember what I just found were the x and y coordinates. So x here is 1/2, y is √3/2. So what's the sine of 60? Remember, sine, when r is 1, it's y/r, so it's just y in this case. Sine is y, so sine of 60 is √3/2. Cosine of 60, x/r, but r is 1, so it's just x. Cosine of 60 is 1/2. So you guys, once I found these values using the concepts of special triangles, things got a lot easier because of my choice of r being 1. All right, we're going to do one more angle before I tell you how to find all of the others in a super fast and easy way using what we know here. So let's erase our 60. So we've done 30, we've done 45, and we've done 60. Let's talk about the 90. In a right triangle, because of where that 90-degree angle is positioned, we haven't found any trig functions for that particular angle. So 90, going straight up. Here's the angle. The problem with 90 is you can't drop down a triangle, right? I mean, if you drop straight down, you're still a straight line. So you guys, you can't create a triangle to help you find the 90 degrees, but you can still pick a point on the terminal side. You guys, what point do you think I'm going to pick? I'm going to pick a point where this distance here is 1. You guys, I want every point to have a distance of 1 from the origin, because that means r is 1, and that means things get a lot easier. So remember, even without a triangle, x, y, and r is how you get all the trig functions. So you don't have to be able to create a picture of it to find x, y, and r. You guys, because we are straight up on the y-axis, finding x and y isn't going to involve any trig at all. It's just going to be, what's the point where we're on the y-axis up at 1? Well, you guys, this is the point where x is 0 because we haven't gone left and right, and y is 1. Remember, r is 1 because I chose r to be 1. So if x is 0, y is 1, and r is also 1, let's find some values for 90. We're not just going to find sine and cosine for this one. I want to find all of them. Sine of 90. Sine is y/r. Remember, r is 1 though, so really sine is just y. So the sine of 90 is just 1. You guys, that's a nice one. Let's talk about the cosine of 90. x/r, but again, r is 1, so it's just x. Cosine of 90 is 0. There's a reason why I want to find the other ones here, because I need to show you something. Tangent of 90. What is tangent? y/x. Our awesome convenient fact that r is 1 really doesn't help us here because it doesn't have an r in it, but I already have y and x, so let's see what happens. Y is 1, x is 0. What's the problem here? I can't have 0 on the bottom of a fraction. What does it mean? It means it's undefined, right? Which is true, you guys. The tangent of 90 degrees is undefined. Let me spell things right. And you can just UND it as undefined, or no solution, or none. There is no tangent of 90. So you guys, what I want to show you here is that sometimes trig functions can be undefined. What you want to know is that sine and cosine always exist. You guys, there is no angle that has an undefined sine or cosine, but the other 4 trig functions that we work with are undefined sometimes. It all depends on if you end up with a 0 on the bottom. So let's find the cosecant. of 90. You guys, remember cosecant is the reciprocal of sine. And I already found sine. Sine is 1, or 1 over 1 if you want to put it in a fraction. So if you take 1 over 1 and you flip it to find cosecant, you're going to get 1 over 1, or just 1 again. You guys, 1 and 1 are reciprocals of each other, right? It's its own reciprocal. So that one was easy. Well, let's look at the secant. You guys, secant is the reciprocal of cosine. Remember, cosine is 0. So if you make it 0 over 1, remember, you can put anything over 1 and it's a fraction. So cosine is 0 over 1, and I have to flip it to get secant. What happens? I get that 1 over 0 again. So for 90 degrees, secant is also undefined. So tangent and secant don't exist for 90 degrees. Let's look at cotangent. Now, because the tangent of 90 was undefined, I can't just take that answer and flip it. So let's remember what cotangent is. Instead of y over x like tangent, it's just x over y. So cotangent is x over y. X is 0, y is 1, so I get 0 over 1, and I do get a cotangent. Cotangent is 0, but it is defined. So you guys, for 90 degrees, tangent and secant are undefined, but everything else is either 0 or 1. So it's a really nice angle as far as trig functions go. And notice, how did I find it? I still picked that convenient point where we were exactly 1 unit away from the center. That made R1, and that made these easier to find. Okay. So we have gone through one quadrant. We've gone through the first quadrant, and we have found the values of all of what we call the special angles. There are special angles in every quadrant. I am going to show you where they are and what values they have. So I am going to draw the 30. Remember, that's also pi over 6 in radians. The 45, that's pi over 4. The 60, that's pi over 3. And the 90, you guys, 90 is pi over 2 if you put it in radians. These are the angles we already know. You already have them written down. But we have more. We have special angles in every quadrant. And I know this looks like a lot of angles, and you think, do we have to find all of these trig functions one at a time? We don't. You guys, this is the beauty of this particular circle I'm drawing. Do you see, well, my drawings are horrible because I'm not a great artist, but do you see the relationship between this 30-degree angle and this angle here that's in the second quadrant? Notice they are both the same number of degrees or radians away from the x-axis. It's a different part of the x-axis. You guys, this is the positive, this is the negative, but if you take each of these angles and drop them down and find how different they are from their corresponding x-axis, you're going to find some similarities. This one's 30 degrees away from x-axis. This one is also 30 degrees away from the x-axis. Look at the 45. Well, obviously 45 from the x-axis to that angle is 45 degrees. But what about this one here? You guys, that's an also 45-degree difference. 60 degrees away from the x-axis. So is this one. You guys, the only difference between angles here and here are the quadrant it's in. It's still creating the same angles according to the side of the x-axis it's on. This is what we call reference angles. So let's start here using what we call reference angles. I'm going to give you the name of this angle. This is 120 degrees. In radians, this is 2 pi over 3. And you say, okay, cool, so it's 60 degrees away, just like that one. What does it mean? You guys, it means that for 120, it's going to have the same exact trig function values as 60, give or take a plus or minus because we're going into different quadrants. So let's keep with this pair. Do you remember, and you might have it written down or you can rewind to refresh yourself, the sine of 60 was root 3 over 2. Well, the concept of reference angles says that the sine of 120 will also be root 3 over 2, but possibly negative depending on what quadrant you're in. So it's the actual value of the trig function there that's the same. It's the same because 120 and 60 are reference angles. They are both 60 degrees away from the x-axis. You guys, so all I have to do is copy what the sine of 60 was and then think about it. Is sine positive or negative in the second quadrant? If you remember, all students take calculus. Student says that sine is positive in the second quadrant. So it is exactly the same. It's positive root 3 over 2. Let's find the cosine. So I remember that the cosine of 60 was 1/2. So it means that the cosine of 120 is also 1/2, but it might be negative because I'm in quadrant 2. You guys, cosine is negative in quadrant 2, so I just stick a negative on it. The cosine of 20 is negative 1/2. You guys, if you remember the numbers for these angles, you know the numbers for all of these angles. So you guys, reference angles are super amazing. Now, I'm going to fill in the names of these angles, or the measures of these angles. You guys, this is 135, or 3 pi over 4. This is 150, or 5 pi over 6. I know this is 180. In radians, that's just pi. Down here, 210. This is 7 pi over 6 in radians. This one, 225. This is 5 pi over 4 in radians. Here, 240. 240 is also known as 4 pi over 3. Down here, what was this one? Remember, that's 270. This is 3 pi over 2. This one here is 300. 300 is also 5 pi over 3 in radians. This here is 315. 315 is also 7 pi over 4 in radians. I'm getting ahead of myself. And 330 is 11 pi over 6 in radians. So this is an important picture because what I have here is all the measures in both degrees and angles, degrees and radians of all of our special angles. Now, I want to add to this, but it's getting a little crowded. So what I'm going to do is make a new one, but you're going to help me make this one. Now, I know if I was in class with you guys face to face, I would actually make you help me with this. I would ask you a question and you would answer and I would write it on the board. But because I can't do that, I guess I'll do it myself. Okay. This is going to be an important picture. Now, this picture is everywhere. If you Google the unit circle, this is what you're going to find, what I'm about to draw. And I would suggest you doing that because my pictures are never great and it's going to be a little crowded, but I still need to create it with you so you know where it comes from. All right, so let me draw in my angles. Notice I'm stopping them at a point. I'm creating a circle. All of these points are going to create a circle. Notice they are all special angle terminal sides. That one's a little off. That's okay. Erase too much. All right, so I've got all my special angles in here and I've stopped them all. Okay, that's way too long. I've stopped them all at certain points. You guys, these are the points where r equals 1. Remember, I chose r equals 1 when I was finding all of those values because it's very helpful, because it basically eliminates one of the variables in your ratios because it's just 1. That's a little high. All right, so notice all of these points that r equals 1. What is r? Well, remember, for any of these angles, r is just the hypotenuse, or the distance from the origin out to the point I've chosen. So all of those equal 1, and that creates a circle, right? I'm not actually going to draw in the circle because connecting those dots would be a horrible idea for me. But this is a circle. This is what we call the unit circle. Why do we want a circle with a bunch of points and angles on it? I'll show you. You guys, let's start with 30. This is 30. It's also pi over 6. Remember I found the coordinates of this point. R was 1. What I found was x is root 3 over 2 and y is 1/2. Let's go to the next one. This was 45, or pi over 4. What did I find for the coordinates of this point? Remember, these were exactly the same. They were both root 2 over 2. Next, 60, or pi over 3. I found the coordinates of this point. They were these same coordinates, but flipped around. X was 1/2, and y was root 3 over 2. I found the ones for 90, or pi over 2. Remember the coordinates for 90 were 0, 1. That's all I found with you, but I'm going to use what I know about these angles and how they reference these angles to find all of the other ones. So you guys remember this was 120, or 2 pi over 3. You guys, the coordinates of this point will be exactly the same as the coordinates of its reference angle. Remember 140, whoa, hold up, 120 has a reference angle of 60. So it means the actual values of x and y are the same, but remember, because the quadrant is different, one of those might be negative. Which one's negative in quadrant 2? The x value. So slap a negative on the 1/2. Now you know the coordinates of that point. This one is 135, or 3 pi over 4. You guys, 135, where's its reference angle? It's the 45. A couple of ways to remember that. If it ends in a 5, its reference angle is 45. Another easy way is to look at the radians. Notice the radians between 120 and 60. Notice they're both over 3. You guys, if it's over 3, its reference angle is pi over 3. Look at this one, 3 pi over 4. It's over 4. Its reference angle is pi over 4. In radians, it's actually really easier to find. But you find them and you reference them. So for 135, it's going to have these coordinates, the root 2 over 2's. But again, because we're in the second quadrant, the x value will be negative. Here's 150, or 7 pi over, I keep saying that's 7. Keep not believing me, it's 5. You guys, 150, or 5 pi over 6. 5 pi over 6, reference pi over 6, or 150, reference 30. It's going to have the same coordinates as 30, but the x value will be negative because we're in the second quadrant. All right, so there's no real concept of reference angles for the quadrants, but these points are easy to find, right? So this is 180, or pi. What is this point? Straight to the left on the x-axis, and I know it's 1 unit away. That would mean x is -1 and y is 0 because you didn't go up or down. All right, let's move on to the third quadrant. This one here is 210, otherwise known as 7 pi over 6. Ooh, what reference angle does this go with? It's an over 6. It means it goes with the 30. We haven't talked about the under angles, right? But how far away is this angle from this x-axis? It's 30 away from the x-axis. That's why its reference is 30. Or just look at the over 6, pi over 6. So it means that these coordinates are going to be the same as these. Again, we're in a different quadrant, so the signs might be different. So you guys, it's going to have the same coordinates as the 30. Root 3 over 2 and 1/2. In the third quadrant, both x and y are negative, so you got to put a negative on both. All right, 225. 225 was also 5 pi over 4. Reference angle pi over 4, right? And it ends in a 5, so it must be the 45. So it has the same coordinates as 45, so it's the root 2 over 2's. But they're both going to be negative because we're in the third quadrant. Here's 240, or let's see, where are we? 4 pi over 3. Reference angle pi over 3. Or if you want to think about it in degrees, 240, how far is it away from this x-axis? It's 60 away. So I'm looking at the 60. So same coordinates as 60, 1/2 root 3 over 2, but both negative. We're down to the 270. Remember, we can't use reference angles for this one, but these are the easy points to find. So this is 270, or 3 pi over 2, straight down on the y-axis, 1 unit. So I think it's 0, -1. Next, we're at 300. This is getting difficult, guys. 300, or 5 pi over 3. You guys, pi over 3, reference the 60, again, the pi over 3. So it's going to have the 1/2 root 3 over 2. You guys, which one's going to be negative now that we're in the fourth quadrant? X is negative in the fourth quadrant, right? Oh, no, I lied. Y is negative in the fourth quadrant. I'm losing my mind. These videos are driving me crazy. So you guys put a negative on that root 3 over 2 on the y value. All right, this one is 315. It ends in a 5, so its reference is 45. This is also 7 pi over 4. Again, reference pi over 4. So it's going to be root 2 over 2, root 2 over 2, but in the fourth quadrant, the y is negative. We're almost done, you guys. This is 330. You guys, 30 degrees away from the x-axis. Or it's also 11 pi over 6, so you know it references the pi over 6. Its coordinates will be root 3 over 2 and 1/2, with the y value being negative. Here, we're back around. Now, I'm going to give 2 values to this angle. We could have started with this angle and called it 0. In radians, it would also be 0. Or this angle going all the way back around is also 360. And I know in radians, that's also 2 pi. So yes, that one has 4 names. But it's just the concept of coterminal angles, right? 0 and 360 are coterminal. All right, how to find its coordinates? Well, remember, this is 1 unit away. I just went straight right on the x-axis, so that's 1, 0. So you guys, there is a lot of stuff to unpack on this picture. Like I said, you can Google this picture. You can print one off and use it while you're taking a quiz or a test. I actually encourage that. When we're in face-to-face class, I actually make my students take a quiz and fill in all of this information, and if they get everything right, then I let them use it. But the way we're delivering this class and everything going on, I just want you to understand it, and I want you to find an image you can use when you're doing quizzes or tests. Why do I want to use this image? Not only because it gives me degree and radian measure for all the special angles, but what's so important about all these coordinates I've labeled here? Well, remember, R is 1 for all of these. We are 1 unit away from the origin for all of these special angles. So remember, if R is 1, it means that sine of any of these angles, y over r, is y over 1. Sine is just going to be the y value. Cosine, because r is 1, x over r becomes just x. This is something you need to remember. On the unit circle, the sine of the angle you're looking at is the y coordinate. The cosine is the x. So, for example, I ask you, what is the cosine of 135 degrees? You say, I don't know, let me consult my unit circle. I find 135 degrees. Cosine is x. Pull out the x coordinate. It's negative root 2 over 2. And it's that easy. I'm done. I found the cosine. What if I want to find the sine of 5 pi over 3? I just got to find 5 pi over 3. It's down here at 300. You guys, what is sine? It's the y coordinate. So it's negative root 3 over 2. So finding sine and cosine from the unit circle is super easy because it's just the x and y coordinates. One thing you really want to get straight is that sine is y and cosine is x. And it confuses us because when we're talking about trig functions, we usually say sine and cosine. When we're talking about coordinates, we always say x and y. It sounds like sine should be the x and cosine should be the y. It is backwards, and you're going to have to ingrain that into your brain because you have to remember sine is y and cosine is x. But if you can remember that, and you have this entire picture to always reference for these special angles, these values are easy to find. Now, you might wonder, what about the other 4 trig functions? Well, we're going to talk about that. And I'm going to erase, don't worry, I have this in my head, so I'm still going to reference my brain version. You can always reference any version you want. Like I said, if you Google it, you can find an image you can save and use this for reference. So let's go back to the 135. Just so you know, since I erased it, at 135 or 3 pi over 4, we had, well no, let me not write the sine and cosine. We had the point on the unit circle at negative root 2 over 2, positive root 2 over 2. This was x, this was y. Using this, let's find more trig functions for 135. So what's the sine of 135? Well, sine is y, right? So the y coordinate is positive root 2 over 2. So cosine and sine is super easy. What about the cosecant of 135? How am I going to find that? Well, you guys, if you know sine, you already know cosecant. You just flip it over. So you guys, let's flip it. So here's the sine, root 2 over 2. If I want the cosecant, flip it. I'm looking at 2 over root 2. Sadly, I do have to rationalize it. But I'm good at that at this point. We probably have done it a lot by now. what do you get? You get 2 root 2 over 2. But you guys, there's a 2 on top and a 2 on the bottom. Here's the cosecant of 135. It just ends up being root 2 once I flip that. Okay, so what about the secant of 135? You guys, remember, sine and cosine, while cosine is negative here, they're both root 2 over 2. If you flip cosine to get secant, what is the value you're going to get here? Well, it's going to look just like this, except with a negative in front of it. So, flip the cosine, make it negative 2 over root 2, and yes, we already did the work here. We get secant of 135 is also root 2, but because it's the reciprocal of cosine, and cosine is negative there, secant is also negative. So basically, if you're looking for a reciprocal function, take cosine and sine and flip them over. The sine and cosine are there for you. All you got to do is flip them. What about the tangent of 135? Remember how to find tangent. It's y over x. You have x and y, right? So y over x is going to be positive root 2 over 2 over negative root 2 over 2. So here's y over x. I know we're looking at a complex fraction here, but I'm going to give you a little tip. You probably already know, but if you don't, you definitely want to. If you're looking at a fraction over a fraction and they have the exact same denominator, you can cancel those out. You guys just cancel them out because they're exactly the same. And what we end up with is positive root 2 over negative root 2. Yes, with the exception of the negative, these are both the same on top and bottom. You could have seen that there too. What's a fraction equal to if it's the same on top and bottom? It's equal to 1, right? This is equal to 1, but remember one of these was negative, so it makes it a negative 1. So you guys, the tangent of 135 degrees is negative 1. The cotangent is going to be a lot easier now that we already have the tangent because I can take tangent and flip it, right? So remember, negative 1, you could also call that negative 1 over 1. Flip it over, what do you get? Well, you get 1 over negative 1, or just negative 1 again. Cotangent's negative 1, tangent's negative 1. One thing I want you to remember when you're doing reciprocals of these things is that flipping a fraction doesn't change the sign. So notice, tangent was negative 1, and I did flip it, but it stayed negative. And that goes for any of those. For some reason, it's like, oh, I'm flipping it, so I got to change the sign. That is not the case. You do not change the sign. So you guys, just by knowing these two coordinates that I got off of my unit circle, I found all 6 trig functions for that special angle. And you can do that for any of the special angles. You will have questions like that. They'll ask some in degrees, some in radians. Remember, on the unit circle, you have both degrees and radians, so that shouldn't be a problem. This one said 5 pi over 3. It could have said 300. Your answers would have been the same. All right, so the last thing I want to do a little talking about is some ways that we manipulate our trig functions. So I'm going to focus on sine and cosine for a minute. The sine of 3 pi over 4, or 135, the one that I just did. Remember what that was? It's root 2 over 2. What if I asked you to find the sine squared of 3 pi over 4? How do you think I'm going to find that? So it's a weird notation. If you have a power here, notice it's not on the 3 pi over 4, it's actually on the sine. What this means, and it's not always squared, it can be any power, it means find the sine of this angle and then square that value. So the sine squared of 3 pi over 4, you find the sine of 3 pi over 4, which I know, because it's right there, is root 2 over 2. and you square it. So you find the sine, then you square it. So when you square, remember when you're squaring a fraction, you square the top and you square the bottom. Make sure you do both top and bottom. You guys, the square root of 2 squared is 2. 2 squared is 4. Reduce that and you get 1/2. So you guys, the sine squared of 3 pi over 4, I took the sine of that, I took that value and I squared it and I got 1/2. So that's how you deal with something that looks like that. What if I wanted, so on this example, this was our angle or our theta. Let's say on this example, theta is, let me think about it for a minute. Let's say theta is 120 degrees. So what's the sine of theta? So I'm wording it a little bit different. I want us to be very comfortable with all the ways trig functions can be laid out. So in this example, theta is 120. How can I find the sine of theta? Well, theta is 120, so I can put that in and say, well, that's the sine of 120. What's the sine of 120? Well, that's a special angle. Go to your unit circle and find it. You guys, at 120, the sine is root 3 over 2. Again, that's on your unit circle, so you can reference that. Okay, so that's the sine of theta. What if it said, what's the sine squared of theta? Well, remember, that would be the sine squared of 120. How do I find the sine squared? I find the sine of the angle, and then I square it. So, what's the sine of 120? That's root 3 over 2. And I square it. Square the top, square root of 3, squared is 3. Square the bottom, 2 squared is 4. So there's the sine squared of 120. What if it asked for the sine of 2 theta? Well, that would be the sine of 2 times 120. So you guys, this 2, you just actually double the angle. So the sine of 2 times theta is the sine of 2 times 120. That would be the sine of 240. So what is the sine of 240? Also a special angle. You guys, the sine of 240 is negative root 3 over 2. Again, on your unit circle. If I had enough room, I would leave that up and so I could show you that I'm referencing it, but I don't. So again, just referencing it in my head. All right, so 2 times, if you see this 2 theta, you actually take the angle, double it, and then take the sine of that new doubled angle. The sine squared, you find the sine of the angle, normal, and then you square that value. Let me see, what else is it going to ask you? Oh, what about this one? Let's stick with theta being 120. What if it asked for the sine of theta over 2? So instead of doubling it, it wants you to half it. You guys, half the angle first and then take the sine of it. So what is theta over 2? Well, remember, theta is 120. So that's the sine of 120, half. So that's just the sine of 60. And then you go find the sine of 60. What's the sine of 60? It's root 3 over 2. Now, there's one more version of theta that it's going to give you. And you guys, I'm using sine as an example here, but it could be cosine, or it could be tangent, or it could be anything. They all work the same. Anytime you have the squared, you find the value, and then you square it. But if you have 2 theta or theta over 2, you actually do 2 times theta, or you do theta over 2 first, and then find the sine of that new angle. But what if I ask for the sine of negative theta? So you guys, you're going to have these problems where there's a negative inside here in the angle. Well, remember, theta is 120. So that's like, for us, saying the sine of negative 120. When you look at your unit circle, you don't have negative angles on there. You only have the positive angles. And sure, you could think about, okay, if I rotate this way 120 degrees, where do I land? You could do it that way. But there is an easier way to find the trig functions for negative angles. And it's to talk about what we call the even or odd properties of trig functions. So you guys, all trig functions are either even or odd. And you might remember a little bit of the concept of even and odd functions. Some functions are even, some are odd, some are neither. But you guys, what works out really well for us is that all 6 of our trig functions are one or the other. There's not one that's neither. And you guys, when they are even or odd, those properties help us a lot. So let's start with the odd functions. 4 of our trig functions are odd, and I'll remind you what it means to be an odd function here in a minute. Sine is odd. Its reciprocal cosecant is also odd. So notice the reciprocal pairs go together. Tangent is odd, which means its reciprocal cotangent is also odd. So these 4 are odd, and you're going to have to remember which ones are odd and which ones are even. Sine and tangent and their reciprocals are all odd. What does it mean to be an odd function? Well, let's look at our example. It means when you put a negative into the input of an odd function, you can actually take this negative out from here and put it in front. Sine of negative theta is going to be the same value as negative sine theta. So you guys, that's a handy little trick. You don't want a negative in here because you can't find the answers for negative angles. If your function is odd, you can take it out. You just have to remember to put it in the front. So before we move on to the even functions, let's finish this one. I say, oh crap, negative 120 is not on my unit circle. Why don't I take the negative out? Oh yeah, sine is odd, so I'm going to take the negative out and I'm going to put it in the front and write this as negative sine 120. I know the sine of 120. That is on my unit circle. What is that? Well, remember this negative out front is going to stay, and then you just do this as normal. The sine of 120 is positive root 3 over 2. But now it's negative because this negative has to stay. So I found the sine of negative 120 by finding this one and using the odd property of putting the negative in the front. Okay, so again, I use sine as an example here, but any of these 4, you can take the negative out and put it in the front. You guys, that only leaves 2 functions that could be even. Those 2 are cosine and its reciprocal secant. You guys, even functions, I wish more of them were even because even functions just work even better than this does. This is a handy little trick, but you guys, I'm about to show you a better one. If your function is even, let's say you take the cosine of negative theta. How does this negative work in an even function like cosine? Remember, your goal is you want to take it out of there. In an odd function, we took it out and we had to put it in the front. In an even function, we get to take it out and leave it out. You guys, we can disappear it. You guys, the cosine of negative theta will be exactly the same as the cosine of positive theta. So if you have an even function with a negative here, take it out. Same with secant. You just take out the negative. So let's do an example with our even functions. So we did sine of negative 120. Because it was sine and it was odd, we had to put the negative in front. What if I wanted the cosine of, let's do 11 pi over 6. We got to get a radian in there somewhere. Or sorry, we're doing negative, right? I want the cosine of negative 11 pi over 6. Well, dang, negative 11 pi over 6 isn't on my unit circle. How can I get the negative out of there? It's cosine. I remember cosine is even, so I can take the negative out And I don't have to put it in front. I don't have to put it anywhere. I can just take it out. The cosine of negative 11 pi over 6 will be the exact same value as the cosine of positive 11 pi over 6. So even, you take it out. What is the cosine of 11 pi over 6? Well, you guys, it is positive root 3 over 2. Okay, so you have some questions like that. And I think that will conclude 5.3. So I know we learned a lot there. What I really want you to get from that is that we have that unit circle. On the unit circle, sine is y, cosine is x, and that you can reference it. That is one thing I never mind you referencing, but I do want you to understand it. If you don't understand it, referencing it isn't going to mean a dang thing anyway. So keep that in mind in the even and odd functions, and that concludes chapter 5 for us. Don't forget, your quiz starts on Thursday. So when I say starts, it opens up, and you actually have till Sunday to take it. So Thursday through Sunday, sometime take that quiz over chapter 5.